All right, so this video's concept is talking about dilations. So I'm going to go ahead and start with some definitions, and they may seem a little abstract at first till we start looking at examples, but I think they'll give us a good foundation for where we're going. So the first word is dilation. So this is an enlargement or reduction, and we'll define those in just a moment. An enlargement or reduction of a shape or figure or something that is proportional. So the proportional portion is the most important part of this definition. It has to be an enlargement or reduction that is proportional. And then an enlargement, we're just, in layman's terms, getting bigger. And that happens when our scale factor, which we'll call K, is greater than 1. A reduction is getting smaller. And that happens when our K is less than 1. And then the scale factor, in essence, is how much bigger or smaller something is getting. So dilations are something that I think everybody's heard of. They may just not have heard them called that way. For example, when you have like a floor plan for your house and they say that your floor plan is drawn to scale, that floor plan is just a dilation. It's a reduction of your actual floor plan, but it's proportional to the real thing. And then a center of dilation is just kind of where it starts or where it gets bigger or smaller from. It's the center that you dilate from. Generally, so this is kind of, I'm going to put this in quotes because it's not a technical definition, but it's good enough for our purposes. Generally, with simple problems and when you're mapping something out for yourself, you'll make your center of dilation at 0, 0 on a coordinate plane. So if you have your shape mapped on a coordinate plane, your center of dilation will be at 0, 0. So these are just different scale factors, and for our purposes, we're going to call our scale factor K. And up here, we briefly said, okay, if it's getting bigger, if it's an enlargement, our scale factor will be greater than 1. And if it's getting smaller or it's a reduction, our scale factor will be smaller than 1. So I'm just going to go through and kind of talk about each of these. So K is equal to 3. Well, that is bigger than 1, so this would be an enlargement. Here, K is equal to 1/3. Well, that is less than 1, so that would be a reduction. And then 3/2 is greater than 1, so that would be an enlargement. 0.67 is less than 1, that would be a reduction. So that's pretty basic, but I just want you to kind of get a feel for when it's going to be getting bigger and when it's going to be getting smaller based on its scale factor. So then if we look at the actual shapes instead of just at a scale factor, we're going to talk about whether they're an enlargement or a reduction. So if I start from the orange and go to the blue, is that an enlargement or a reduction? Well, I think it's pretty clear that it's an enlargement because from orange to blue, it's getting bigger. Versus over here, from green to purple, it's getting smaller, so this would be considered a reduction. And then we've got to be able to find our scale factor based on that. So the easiest way, I think, to find a scale factor is to just pick a point from your original rectangle. So like this point is at 0, 1. And then that same point after the dilation has moved to 0, 4. Now it's very important that you use the same point. I shouldn't pick this point on my original and then this point afterwards. That's not going to work. So if we look here, 0, 1 and 0, 4. Well, what do I have to multiply these two numbers by to get these two numbers by? In this one, it's pretty easy to just see. I multiply them by 4 because 0 times 4 is 0, 1 times 4 is 4. And that would work with any one of these points. Say I used B, that's at 1, 1, and then my other B is at 4, 4. So I'm multiplying by 4. If it's not so easy to see, here's a way you can kind of set it up. So I know that 1 times some sort of scale factor, I'm not sure what it is, has to then get me to 4. Again, you've got to make sure you're using that same point. So the 1 and the 4. And then 1K, well, if I divide by 1, 4 divided by 1 is still just 4. So my scale factor is 4. So you can find it mathematically like this, or sometimes it's easy to just kind of see it without working it out. So we'll talk about that same thing over here. This time we're going from green to purple. So I'll pick this point, Q, and my Q point is at -4, 4. And then this Q point afterwards is at -1, 1. So what do I multiply -4, 4 by to get to -1, 1? So I know this is a reduction. So I know that my k has got to be less than 1. So it's going to be some sort of fraction. Now some people are pretty good at saying, well, you're dividing by 4, because -4 divided by 4 is -1. 4 divided by 4 is 1. Dividing by 4 is the same thing as multiplying by 1/4. Again, if that's difficult for you to see, and there will be some that most people can't see because you're going to have to, it's going to be like 5/6, which is really hard to just be like, oh yeah, multiply by 5/6. So we can set up a little equation. So 4 times some sort of scale factor k has got to then end up as 1. And if I solve for k, I divide both sides by 4, and k is equal to 1/4. So that's my scale factor. So that's kind of the basic process for finding our scale factors. In our next examples, we're given some scale factors, and then we want to graph our new point. So k equals 1/4 is my scale factor. For this one, I'm going to go ahead and list all the points. I think it's a little easier that way. If you can figure out how to do it without doing that, that's completely up to you, but I think that it's a little bit easier to just list the points. So I'm going to go ahead and do that. R is at 8, 8. S is at 8, 0. And then when I list my new points after the dilation, I'm going to put an apostrophe right here, and this is said Q prime. So I've got to multiply each of these by 1/4. So -4 times 1/4 is -1. 4 times 1/4 is 1. P prime becomes -1, -1. R prime, 8 times 1/4 is 2. So this becomes 2, and 0 times 1/4 is 0. So here's the points for my new figure. So I'm going to go -1, 1 is about right here, and that's Q prime. And then -1, -1 is about right here, that's P prime. 2, 2 is R prime, and 2, 0 is S prime. So I'm going to go ahead and connect those, and there's my dilated figure. So then it's the same process over here. You're going to want to list all 4 of these points, multiply them by 4, and you'll get your new set of points. So I'm going to go ahead and just draw them without listing the points so that you can check your answer, but I suggest you try it, pause the video and try it, and then come back and see if your answer is correct. So this is my new figure, and it becomes labeled A prime, B prime, C prime, D prime. This one starts at -1, -1. Scale factor is 2, so this point's going to go to -2, -2. 1, -1 is going to go to 2, -2. And here, and here. Go ahead and connect those points. And I have A prime, B prime, D prime, C prime. So those are just a few examples of dilating figures. We're then going to talk about finding scale factors when we're not given the actual shape, we're just given the points. So T is one of the vertices of our original triangle, and M is the vertice afterwards. So I can totally set this up by doing 1 times some sort of scale factor is going to equal 2. So 1k equals 2, or k equals 2, which you also can see just by looking at it, because you can see 1 times 2 is 2, 5 times 2 is 10. Same idea over here. 4 times some sort of scale factor equals 2. So 4 times some sort of scale factor equals to 2. Divide by 4. K equals 2/4. which is the same as 1/2, which you can also see because half of 4 is 2, half of 8 is 4. And then because I can never not have a typo, this is actually should be -30. So I can do -3 times k equals -15 divided by -3. -15 divided by -3 is 5. And I can check it because -6 times 5 is -30. So that's just really quickly how you can find those scale factors. Even if it's not drawn for you, you can just use the points to do that. This section is talking about finding the dilations of line segments, and I'm going to go over it pretty quickly because it's not a huge concept. But if I go ahead and graph my first points, so I have a point at 1, 1, and 3, 3, and there's my line segment. And then I want to graph the dilation, so I've got to multiply by 2. So this becomes 2, 2, and this point becomes 6, 6. So if I plot those points, 2, 2, and 6, 6, there's my second dilated line. So notice that yes, it's an enlargement because this is greater than 1, so my line gets longer, but it's the same, it's on the same line. The reason for that is our center of dilation at 0, 0 is also on that line. So if your line goes through 0, 0, through your center of dilation, then your line is going to stay the same. If your line does not go through 0, 0, like say it goes through right here, then your dilated line is going to be parallel to your original line, but not the same line. And that's pretty much all I want you to know from this, is that if it goes through that center of dilation, goes through 0, 0, you'll have the same line after you dilate. And then if it does not go through 0, 0, you'll have a parallel line after the dilation. This little section right here is talking about determining that center of dilation we were just talking about. And it's kind of difficult to show you on here, but I'll do my best. So if I have two shapes, if you connect the parts that match, so like I draw a line through these two, through these two, through these two, through the connecting parts, and if I were to keep drawing, keep drawing, keep drawing, they all intersect at one place, and that is called your center of dilation. All right, so the last section of your notes is talking about finding missing values, and this is where that proportional thing is so important. So we know that they're proportional because they've undergone a dilation. So that means this proportion to this proportion is the same as this to this, is the same as this to this. So I can find missing values using that logic. So like, for example, my y right here, the corresponding line in my second shape is right here, which is equal to 12. So that has to be equal to 10. And again, since I started with this shape is my top part, this shape also has to be my top part, so I have a 10 here, over 5. Once you have this proportion set up, you can solve for y by cross multiplying. So y times 5 is 5y. 12 times 10 is 120. If you divide both sides by 5, y equals 24. And it's the same idea over here. So 5 over x is the corresponding line. And then I have to start over here again. Is equal to 7 over 14 is the corresponding line. Cross multiply, and I have 7x equals 70. Divide by 7, and x is equal to 10. So then we just have one more question to talk about, and it's asking if from this television, your old screen to your new screen, if it's a dilation. The answer is definitely no, because if you look here, this goes from 20 to 16, so from here to here is a reduction. But this goes from 5 to 9, so from here to here is an enlargement. So there's no way that's proportional. So they're not proportional, so they can't be considered a dilation. So those are the basic concepts that I think are very important to understand when it comes to dilations.